This lesson is on naming fractions and models of fractions. The goal for today is that students will understand the parts of a whole must be equal to determine an entire measurement when given only a fraction of the entire measurement. This lesson today should be mostly review for you. So we know that parts have to be equal for either of the two pieces to be a half. So here we have four drawings. Do these represent 1/2? Well, if we look at them, we know that this one, it does represent 1/2. 1/2 of the circle is shaded. This one does not because it is not equal. This one does not because it is not equal, and this one does because it is equal. So again, we need to remember that parts have to be equal. So if we look at these two diagrams, which one of these two illustrates 1/4? Both of the circles are divided into 4s, but one of them is equal and one of them is not. So obviously this one here is divided into 1/4 because all of the parts of the circle are divided evenly. Now, a sport is played by witches and wizards on brooms that has a rule that the players must fly higher than 5 meters above the ground over certain parts of the field. This is shown as the shaded parts in the diagram that's on the screen. So over what fraction of the field must the players fly higher than 5 meters? So first of all, we need to find out how many parts there are of the field in total. So we see that 1, 2, 3, 4, 5. We have 6 kind of squares by 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 times 9. So we have, there's 54 areas of the field in total. So we're going to put that on the bottom number of our fraction because there's 54 total squares in this diagram. Now we need to find out how many of these squares are actually shaded. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 on this side too, so 16. I'm just going to put dots in them knowing that we've counted them. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So we know that there's 32 areas on this field that are shaded. So 32 areas are shaded, 54 areas of the field all together. So that's telling us that 32, a fraction of 32 of the field that the players have to fly higher than 5 meters. Now, anything can be divided into equal parts. It's not just shapes like circles, squares, triangles that can be divided into fractions, but anything that can be divided equally can be divided into a fraction. So here we have a line segment on the picture. How can we take this line segment and divide it into equal parts? So where do you think it would be half for this line segment? Well, probably about here if we want to just guess. But how can we know this for sure? What could we do? Well, we could measure it, absolutely. So we could take this ruler and we could measure this line segment. So we know we can line it up with 0. I'm just going to put a little dot here for where the 10 is so that we can just slide our ruler down and continue measuring. So this line segment is about, let's say 11 centimeters roughly. So where would half of that be? Well, what's half of 11? Half of 11 would be 5.5. So we were really close to being halfway. So there would be about half. So we can always measure a line segment to find out how to divide it equally. So here we have the line segment all the way at the bottom in the thin black line, and then this is the thicker black line. So what fraction of the line segment is a double line segment? Okay, so the double line segment is one part of the line segment. So right here is one part. So this double line segment, the thicker one, if we measure it, is 2.5, just over 2.6 centimeters long. So if we want to find out how many or what fraction of this the full line segment is, we need to know how long the full line segment is. So if this is 10 So the whole line is 13 centimeters long. So now we're going to find out what fraction of this. So right now it's 1. We know this is one part of it. There's only 1. But we are going to see how many of these double sections we can fit. So there's 1. Now we're going to measure 2.6 again. And I'm going to put a little red dot to show where the second part of that line segment would be. So there would be 2 if we had 2 of them. Now we can move our ruler down, find again 2.6, that would be 3. Move it down again. This would be 4. And then that should be 2.645. So we would say that this fraction of the line segment is 1/5 of the whole line segment, because we can take this thicker part, the double line, and have 5 of them that make up that full line. Okay, now what about this one down below? So now, oops, sorry, don't have my arrow. This line segment's a little bit thicker, so we need to measure it first. We can see that this thicker line segment is 4 centimeters long. Now if I measure out 4 centimeters again, here would be 2 of them if I had another one, and then this should be 4 centimeters, just about. You can tell that these slides are not very accurate. So we would say that here we have 1/3 of this full line segment is thicker. Then if I measure this last one down below, this one here is, we'll say 2.5. So we'll measure out 2.5. That would be 2. Measure out 2.5. That would be 3. And then this would be your 4th. So this one here is 1/4 of the line segment. Okay, and then one last one, just in case. Now it's only 1 centimeter long, so we can tell that there's another one here. So 1, 2, if we just know how long this line is, we'll know how many line segments there were. So we can see that this line's about 10 centimeters long. So this would be, this one should be 1/10 of that line segment. Okay, now we can do the exact same thing with squares. So let's express the fraction of shaded squares in each of the following rectangles. Well, in this rectangle here, we have 4 squares all together. So the 4 goes on the bottom because it's the total number of parts. And we have one of those parts that are shaded. Now here our squares are all equal, so it's easy. Again, there's 4 squares in total that are equal, and 2 of those are shaded. Here we have 5 squares in total, and we have 2 of those shaded. Now if we move on to the next ones, we notice that these are not equal. We're missing parts. So I need to first figure out how these would be equal before I can give you a fraction. Okay. So how do we find the shaded fraction if we're not given equal squares? Well, we first need to figure out how these are equal. So if I use my ruler, I could measure this square and look above to see there would be 2, sorry, to pretend that's straight, there would be 3 to get my equal squares. So this one would be the exact same. It's still 1/4. I just don't see the equal squares. This one here, if I put this down here, would be the same as 2/4. And then this one here would be just about like the one above. It's just missing those lines in it. It would be the same as 2/5. So let's go on to this question here. So I am giving you one square. I want you to extend the square so that the shaded part becomes, so this is your shaded part, I want it to become half the size of the extended rectangle. So I want you to extend this square into a rectangle that this is half the size of. So that's half the size. I need to basically double that. So that would be it doubled. Okay, so it's now the shaded area is half the size of a rectangle that I've extended. These parts are both equal. So now I can say the shaded area is 1/2. Now, if I want to do a third of the size of the extended rectangle, okay, so this would be, that would be half. Now I need to clone this one so I know it's the exact same size. And that would be a third of the extended rectangle. So now I could say that I have 1/3 shaded of the extended rectangle. And same with this, a quarter the size. So now it needs to be a quarter, meaning I need 4 shapes all together. And they all need to be equal sizes, so I need to make sure that my sizes are the exact same. So there would be 1, 2, and 3, and now I have 1/4 of the extended rectangle, and all of my parts are the exact same shape, or exact same size. So now if I want to extend the square so the shaded part becomes 2/5 the size of the extended rectangle, I want to have then 5 of these squares with 2 of them being shaded. So right now I have 1, I need 2, 3, 4, and 5, but 2 need to be shaded. So I need to shade this one into gray to make it true to be 2/5 of the extended rectangle. Now here's some exercises for you to do on your whiteboard. You will need a ruler to complete these as you are drawing line segments, and you need to measure how long the line segments are. I want you to complete these on your whiteboard, so pause your screencast, and then when you are done you can continue on. Now one last part before you begin your assignment for today. How many equal parts are in each shape? What fraction of each shape is shaded? Well, both of these are both representing the same thing. They're both representing 1/4 shaded. It's just that the shaded areas are different. One's a square, one's a rectangle. Do they have the same shaded shape? No. Do they have the same shaded area? Yes, because in each case the shaded part is one of 4 equal pieces. So no matter what, they're both going to be 1/4. Now if I give you this one, what fraction of the figure is covered by the shaded triangle? Well, we can see that 1/4 of this figure is shaded by the triangle. So if I were to also split this square the exact same way as this one, there would be 4 triangles. So 1/4 would be shaded by a triangle. Then if I asked you what fraction is covered by the small square, you would say that 1/8 is covered in the small square, because each bigger square could have 4 smaller ones if divided, wow, that's a really straight line, the exact same way. It would be 1/8. For today's assignment, you're going to complete page 140 to 141. If you finish and you would like a challenge, give the extension questions a try that are posted onto your Power Learning.